So, hello everyone. Um, Good morning, good afternoon, and good evening. Welcome back again to the Sky Pro Guide session. I'm Dr. Johnson, and this is our second module. So, those who have attended the first module of Sky Pro Guide, uh, you must be aware that this is a real guide software version for Bredent users. And the first module we had how to download the software and also the overview of how to do a single implant and guide creation. If you have missed the first module or if you want to review again, uh, you can scan this code and it will take you to YouTube and you can revise or you can see the first module again in YouTube, or in YouTube you can just Google search, YouTube search SkyPro Guide software and introduction to single implant, and you will find the YouTube video in that. So today we'll go to the second module where we'll be talking about importing, exporting of STL and DICOM files and also editing the STL files, matching and aligning different STL files and DICOM files. So this is a very important topic where it helps us to do a lot of manipulations and play around with STL files. I'll be showing few tips and tricks which can be applied in various other situations. And today's topic is all about data management and editing of STL files. So before getting into the software, I would like to explain how the STL files are organized. So every STL file has its own coordinate system in X, Y, Z axis. Every STL file is at its own address, and the address of that particular STL file is defined by from the origin of the STL file. For example, intraoral scanner or a lab scanner. When you scan it, and when it is captured, when you arrange them in occlusion, and then finally when you save the file or you export from intraoral scanner to export as an STL or .obg, it comes with its address. And when you import that into any other software like exocad, 3Shape, or skypro guide or co-diagnostics, anything, it copies the same address from the origin address. For example, this is upper to a scan 1. It has its own xyz coordinates, and this is lower scan with other different xyz coordinates. These two are very in very different positions. This happens when you have used different scanners, or if you have scanned in different files, like patient 1 and patient 2, or if sometimes you have used different softwares. So what happens is when you scan 1 and scan 2 in different coordinates, and when you bring them into a third-party software like SkyPro Guide, they come in the same coordinates and they are not in relation with each other. So we don't want this to happen. So the best thing to do is always scan the upper and lower in relation to each other. So when this happens, and then you get a right occlusion, both upper and lower have their own individual address, but they are in relation with each other. So this is a very important point you have to remember, and you have to follow the scans, because it is near to it is impossible to manually match the upper and lower occlusion in a right way. It's always better to have occlusal scan perfectly. Then same thing goes with STL on STL. For example, this is an edentulous jaw, and this is a denture. When a patient comes with existing denture, you scan the edentulous jaw with some kind of landmarks, and also you place the denture on the edentulous jaw and scan again. So you have two STL files, but in relation. That's how you get this kind of STLs, which we need sometimes for when we plan for edentulous cases. Now we have STL and we have DICOM. STL comes from intraoral or lab scanner. DICOM comes from the CBCT machines. Both are different machines, different software. So of course, it will be different files. DICOM comes in a different format. STL or OBG comes in different format. Now here, important point to remember is we need some kind of landmarks so that these landmarks will help us to match each other. Like for example, the molar, and the other molars and the anteriors. Some important, if possible, hard tissue coordinates are required to match these. So this is in basics of matching of STL files. So any questions here? Is this understood? So I hope there are no messages. So I hope this is understood. Tobias, I'm audible, right?
Yes, you're audible, and at the moment there are no questions in the chat or in the questions and answers.
Yeah, okay. That's good. Thank you. Thank you, Tobias. So let's get into the software. In the first session, I've explained a little bit about software interface, so I won't get into details of that. We'll get into the case. So this is module 2 and 2.1. So add a case. Now I will import a DICOM folder. So my files are here. I will start with a single unit just to show how it goes. So here I import the DICOM file, select folder, and I'm importing the DICOM file here. Okay, now let's import the job which we need to work on. So again, anatomy. This is for importing the STL file. Click on import. And have an upper anatomy file here. I click on anatomy. Okay. And then I can go for antagonist here. Click on antagonist. And then close it. Close it. So here we see upper and lower. Anatomy means the jaw you're working on, you're planning for implant, and antagonist is of course the opposing arch. So here we imported CBCT, the DICOM file, and we can check here. How is it? Now here we open it. So here we have objects. For now, I will switch off the objects. I hope you're able to follow my mouse. So here I switch off the objects. And now the steps of how to go on with the case are here. For example, this particular case, first I have to clean how it looks. So I'll go to the volume settings first, and then if you see here, it's the soft tissue which we don't need at the moment. So I'll go with the volume options. I clear this. I'm cleaning the CBCT and approximately check my interest. Tooth of interest is 1, 2. Yeah, it's fine. Then I can go back and I can switch on the trimming, and I can remove whatever I don't need as in bulk. For example, in this case, I don't need the lower, and then I don't need all this stuff. And then I don't need this. Once you're fine with this, then we go for permanently trim. And then we can use start sculpting. Sorry. And with start sculpting, I can just click whatever I don't need and then sculpt it. You can see that, for example, I don't need to remove all this, but just to show start sculpting, I can and sculpt. Start sculpting. Yep. So like this, we can sculpt the CBCT files. Once we are satisfied with CBCT file, then I can go to, say this is anatomy file and this is antagonist. Fortunately, the anatomy file is matching, but still once I will show how to match both ways manually or automatically. So you select the anatomy file and then go for matching. And then in the matching, you see STL on DICOM. So click STL on DICOM. The object name is anatomy. The, the objective of the anatomy file is to match the DICOM here. So here we click OK. There are two options. I will show you both the options. One is AI, that is assisted. Click on assisted. And then it will match automatically. So we can cross check here if it's matched well or not. See this, it's matched well. If at all it doesn't match, then you can go by points. I will cancel this. Undo. I can to cancel this. And I will match again, matching STL on DICOM. Okay. And then by points. So I see some similar as I showed in PowerPoint. I will go here and try to match some points. Okay, so molar and molar cusp here. This one and this one. Maybe molar here and molar here. So some 3 to 4 points. If at all it's not matching by AI, this is how you can go and then say fit points and again best fits. So this works well. Also, if you think it's not matching well, then the only option is you have to try again and again. Maybe you can reduce the diameter, the matching diameter, for example. So what it does is it increases surface area of the matching point, this matching diameter with this. So it will take more area to match. For example, here you see this, the surface area of this has increased. See here, you can see the surface area is increasing. So it will take more surface area to match to this. So you can try to match that way. Okay. I hope that is understood. And now, if you see the antagonist, if the antagonist is not in this position, how do you match antagonist? You go to matching. Now here you don't do STL on STL. You go again STL on DICOM. Here the object name is antagonist. And now you don't select here matching. You select here same as anatomy. Why we are selecting same as anatomy is the upper had its own coordinates. The lower has its own coordinates. When it originated from the scanner, from the lab scanner, they both came in their own coordinates. So now I moved the upper to another position. Now I'm telling the lower to go to the same coordinates as upper. So same as an anatomy as upper. When you say this, automatically the upper and lower will come in occlusion. I hope this is clear. So again, you have to click on antagonist. You have to go to matching, click on STL on DICOM, and you have to click on same as anatomy, and then click OK. This is how you match upper and lower. Now, for example, this particular patient has come for implant for 2-2, and then you take CBCT, you take intraoral scanning before extraction, and now you want to plan the extraction with the wax, and you also want to have wax up of this particular case. So what we do is we can do digital extraction. Now this is CBCT file. Here X marks you can show or hide the DICOM file. Click this, it will hide. Click this again, it will show. So I'll hide this for now. I will see anatomy. We want to extract this digitally and also have wax up of the same particular teeth for next steps of prosthesis. So I can go here and I can see here duplicate object. So I duplicate object here and I can write a name as wax up. Click OK. And now I have wax up. I want to change the color of wax up. Change color. Maybe I'll take something like off-white. And then click OK. So now I have wax up and anatomy file both. So first, let's do the extraction. So I select anatomy here, go to editing. I'm trying to be as slow as possible, but I'm not sure if I'm too fast. If you're not able to follow, you can please tell me. You can stop in between. So anyway, I don't like this. It's disturbance. So I can go here by cut. I can click on area and zoom and select some part and then say cut. Again, click on area, cut. So likewise, you can just click on area and select any part you don't want, and you can click on cut. It will remove through and through. But for extraction, you need to select something else. So that is spleen. So you select the margin of 2. So if you see, the software is automatically try to select the entire teeth. So according to this, the darker area is going to be cut and the lighter area is going to be saved. We want it in reverse because we are doing digital extraction of this teeth. So here I will say invert cutting area. So I click this. Now this has become dark and now I say cut. So it has removed the teeth here. Now we need to fill it with the something called like extraction socket or the gingiva. So here we see fill holes. Click on fill holes. It will detect the wherever there are holes in the model that is marked by red, and then we click on the one which we want to be filled. Now we click on this, and here we have few options. If you want flat, it will give flat. Curved, it will give you convex. Round, it will give you concave. Depends on the situation. For this, we need concave. It will give you approximately concave. So we have to click on fill. So it has filled the socket. Now you want to create it like to look like socket. So here we have freeform tools. We can add, we can reduce, we can smooth, or we can add in patches, pull it out. We have so many options here. So we'll go to reduce, and I can increase the size of the tool, the circle, or I can increase the power of the tool. Now I go here and reduce. You can increase and decrease the size of the tool by holding shift and rotating the mouse, or you can increase or decrease the strength of the tool by holding control, and you can increase or decrease the strength of the tool. Now I want to smoothen it up. Okay. So this is how a digital extraction is done. Now I can apply changes. Now we have one more file of WaxUp. Now this tutu we want to use as WaxUp. This I am showing you the tools and options. There'll be various. I have done so many cases. There are various other situations where I had to use this particular concept. What I'm going to share with you. There are various other situations I had to use these tools, like making a model much better or making a crown much better, because this SkyPro guide also has crown and bridge options. So I have used this in various other situations, but once you understand how the tool works, you will use it accordingly. So I selected, I'm sorry, I'll just go back. So I selected WaxUp. I clicked on edit. Same thing, we need to select the particular tooth, spleen, and click on the margins of the tooth. So this time we want to save this particular teeth and delete everything else. So we won't do any inverting, just cut it off. So now we have only teeth, and it looks like this. But in any case, since this software also has CAD prosthetic design options, we might use this as a wax up for future crown after planning the implant. So we cannot send this as a wax up with this defects. So what we can do is there is something called border restoration or border straightening. I'll just show you. This is nothing but you have to the thickness you have to select and it will smoothen that surface, clear that surface. This is good for models, and for restoration you can go click on border restoration, boundary restoration, and then you click from one point to another point where you want to restore, and now you see it's filled with this, and now you can go here and pull it out to give it that crown contour, and you can make it smooth and say apply. Same thing on the other side. So basically you are building the proximals. Apply. So now you have both the proximals. Click on smooth tool. You can reduce the strength a little, you can reduce the size a little, and then smooth the whatever you have made the contacts, you can just smooth it up. Apply changes. So now we have jaw with extraction socket, or we have wax up ready for implant planning, followed by crown designing using this wax up. So is it understood till here? Any questions here? If at all you have missed some thing to import in the first initial stages of where we have imported the STL files and DICOM file. If at all you have missed something, then you can always go to import here and select what are you planning to import again, and with what do you want to match. Match as anatomy, click on anatomy, click OK, and then look for where is the file, click on that, click on the file and press OK. So I imported one more file which I had designed a crown previously. So it matched well with the anatomy file. If at all you have to match, if at all imagine it didn't match for some reason, you had different STL files. Okay. So for some reason you have different STL files. The patient came now before extraction. The patient came now. This is before extraction, and then you saved a file, and then after extraction, then tells you that I want to plan for implant, and you have after extraction you have one more file. These are two different files. They both are not matching because their coordinates are in different position. How do you match them right now? Is of course you need a good hard tissues or landmarks. Then you go here, click on you want to match with the present STL file, the fresh scan of the patient, go to matching. Now this time it's not about STL on DICOM. This time you want to match STL on STL, or even the denture base or something. When there are two different STL files from two different sources, basically, click on STL on STL. STL, sorry. Now here you select which file you want to be matched. So my main core file will be anatomy. This is my core file, and this is my old file. What is this? Yeah, this is my old file before extraction, and this is my fresh file after extraction. So either I can click on assisted. Assisted will do a fantastic job. And it will show you the blue being the zero errors, I mean zero discrepancy, and pink being the highest discrepancy. Since we know that we have done extraction here and we have the original file has a teeth here, that's why it's showing pink. But otherwise, the matching is perfect. This is automatic. Otherwise, we have by points. Click on by points. Go here. By points or by brush, it's the same thing. I always recommend to have 3 points, 2 posterior and 1 anterior. If possible, one of the posteriors can be like this, and one more posterior can be on the gingival surface, so that not just the occlusal surface, but also the z-axis can be matched well, not just the xy axis. Even the z-axis is the long axis. Z-axis should also match well. So I will go to this margin here. I select this margin here and the tip of this, and then click fit. So there is some error here, but if you see here, it is proper. Let's click OK. So you see here, it's not matching well. There is some discrepancy here. So you need to match again, but assisted works fantastic. Assisted has corrected it. So if by points it doesn't match, you have to keep try it again and again with different possibilities until you feel comfortable. Then click apply changes. So until here, if it's clear, then I will go for double scanning or edentulous jaw. Till now here we spoke about dentulous jaw. So I will exit this case, save project, yes, save project. So now the next is module 2 double scan. Okay. So what is double scan? I will explain you as I import and start editing it. So here it's used for edentulous jaw where you don't have any hard tissue surface to match anything. We make hard tissue surface to match. So here it is double scan. When you click on import DICOM project, double scan, click on double scan. Now let me see. My double scan is the lower jaw case. So I'll click on the lower jaw. It is a DICOM file. I click on DICOM file. So double scan. Okay, so this is the DICOM file of lower jaw, lower denture basically. Select folder. So it's importing. Okay. Likewise, I can double scan and import the upper jaw file. Okay, for now, I'm doing just one. lower jaw. And then we need to import a regular DICOM, a bone. It's a complete CBCT. Select folder. So here you see lower jaw, and here you see the complete CBCT of a patient. And this is the denture, and this is the patient scan. Okay, so first thing is I open the lower jaw, click on open. If this is new for you, then until this will be a little confusing right now, but by the end of this session, you will understand what happens. So this is nothing but CBCT scan markers. So I'll go to volume setting. Here I'm not able to see anything properly, so I try to correct this my CBCT file, and I think this is fine. So this denture has we stick these CBCT markers in few places like this, labially and lingually, and then we scan this particular denture with the scan markers in the CBCT machine, and then we get the DICOM like this. So this is one. And then here you see the second option, segmentation. Click on segmentation. So it says 8 markers have been detected. Click on this. So this automatically separates the marker. You can see the markers here. You can zoom in. Okay. So if at all the markers are not clear, you can play around with the toggle here, and you can make the marker a little better. So fortunately, system automatically detects most of the time very well. Once you are satisfied with the view that markers are round and clear, click on segment. So what it is doing is it's taking out the markers as a separate file from the denture. Now the denture is joined. Now it's taking out it separately. If you want to smooth it, you can smooth it. It's already smooth. So I just say apply. The next is processes. So processes also I try to check how is it. And then if I think I'm satisfied with this, then I click segment. So it's converting this also into an STL file from DICOM to STL file. Now here, this particular file still, of course, this is the now STL file. Now, whatever I don't need, for example, this particular small thing I don't need, cut by area, click on this and remove whatever I don't need, cut by area. This isolated components is if anything is left out here and there, then it will remove those components. And now I want to remove these points. I can go to minus, increase the tool size, and just click on this. And smooth the surfaces. It's actually good. Nothing to change much. and then smooth. Apply. So now we have one STL file of denture and STL files of the markers. Now here we click finish. So here if you see objects, we have one STL file of denture and one STL file of the markers. So why was it required? Now we go to the actual CBCT. Click on open. See, nothing is matching here. So first thing is we switch off the objects disturbance. So now what we did, what the case was. So first we keep the scan markers, the CBCT scan markers. We stick them to the denture, place it in the patient's mouth, and then we scan the patient with the scan markers. With the denture in the patient's mouth, we scan it like this. So the bone is recorded and the scan markers are recorded. And the next scan was just the denture and the scan markers we have recorded in the CBCT machine separately. So now here we don't need upper. I'll just remove whatever is not required. And permanently trim. And this one was upper marker, so I'll just start sculpting and I'll remove this first. Start sculpting and we can just remove whatever we don't want. Sculpt. Okay, so next step. So it's understood. Now we have, as this is access to switch off the DICOM, and this will switch on the files, whatever 3D files are there. So we have jaw file, also we have markers here. Now the next step is, of course, we have to do matching for planning. So we go to the marker and then say matching on. So we have to match these markers with the DICOM. So click on this, the lower marker matching, click OK. Scan marker file located, OK. Sorry. So it went into hiding. So volume settings were moved, so I moved it back to correct position. Now I'll go to matching, then go to, I selected the markers, go to matching with STL on DICOM. So the marker STL files are on DICOM. Then click OK. Sure, what is happening with this guy? Let me start it again. permanently trim. Okay, next is matching. Click on this, matching on this DICOM. Yep. Okay. Okay. Anyways, so these these are the scan markers, and this is CBCT markers. This is STL, and this is the DICOM file. Uh, it's automatically matched without clicking anything because it has detected that. But still, if it doesn't match, then you can always click on assisted. Then it'll match automatically and apply. Even the prosthesis, when the software detects automatically, double scan protocol processes copied position from the STL markers. So even the prosthesis is matched automatically. We did not do anything. So however it was scanned, it was in CBCT machine, and with the markers, exact positions have been mapped. So now with this, we can proceed to do implant planning. So that's it for double scan, and then we go for implant planning. We will be doing this on another session. So any questions here? I don't see any questions as of now. So the next session will be next month. We will send you the date again. Since you have already registered to this, you will automatically receive an email with the new date. The next session will be implant planning workflow, abutment selection and rotation of the abutment, the angulation, how do you rotate, how to give right angulation for particular case, and other tools to the inbuilt tools to how to measure the bone density or the distance of bone to implant or the height of abutment. All these things will be in the next session. It will be little in depth of implant planning section. So it will be in month of February, but I'm not sure when is the date, but we will announce you the date. So I hope you learned something new today, and thanks a lot for joining this session. If any questions are there, I'm here for another few minutes. You can ask.
Well, I can add or I can say the next session will be on February the 18th on the same time. And
Okay.
it doesn't seem that there are no questions in the chat and no in the questions and answers, and nobody has raised his hand. So
Yep. Okay, then I think it's clear. We will see you all next month then. Thank you.